Alright, let's describe all transformations to the function f of x in words and in mapping notation. Okay, so if we're looking at writing all the transformations in words, we will always have to be doing our vertical and horizontal modifications, which includes vertical stretches, shrinks, reflections, and horizontal stretches, shrinks, reflections, and then we'll do our translations, so our horizontal and vertical translations. I like to think about it from left to right, I would go this way. So the first transformation here, I can notice here that the a value, and you want to always think about the template as y is equal to a f of k x minus d plus c, okay? And you can notice here that the first transformation here is referring to our a value, which is a vertical stretch or shrink factor, right? So a here is 1/2, k here is 1/4, right? So 1 over k, which is the factor for the horizontal stretches and shrinks, is 4, right? D here is 5, and C here is 6. Okay, so I'm going to use these values to write down my transformation. So the first transformation I can see here, there's a vertical compression or shrink. Or you can use compression as well, it's the same thing, by a factor of 1/2. Okay, so in terms of function notation, what that really basically means is that we have 1/2 f of x. Okay, so this is the function notation writing it. Our second transformation, we have a horizontal, because 1 over k here is 4, we have a horizontal expansion or stretch by a factor of 4. Okay, so we can write that here as 1/2 f of 1/4 x. Okay, so this builds our function piece by piece. Our third transformation here is basically a horizontal shift . 5 units to the right. So if we have a horizontal shift 5 units to the right, we can write this guy here as 1/2 f of 1/4 x minus 5. Our fourth transformation here is a vertical shift . 6 units up. Okay, so if we have a vertical shift 6 units up, then basically we're going to have the equation 1/2 f of 1/4 x minus 5 plus 6. So this is basically what our transformed function looks like, right? So I can just show you guys what it means piece by piece. Now, using mapping notation, I want to look at all the transformations I did to x and y. So the transformations I did to x, I had a horizontal stretch by a factor of 4, so I multiplied all my x values by 4. I had a horizontal shift 5 units right, so I added 5 to my x values. For my y values, I had a vertical shrink by a factor of 1/2, so 1/2 y, and I have a vertical shift 6 units up, so I added 6 to y. Okay, so this is what our mapping notation will look like, right? This is what the transforming equation is, and we can use this to change our points x and y in our function f to our function g of x, which is a transform function.